Thank you very much if you're attending my session on Roman numerals. As I said in the introduction, my name is Mark McCourt, and I'm going to talk for a little while on some of the issues around Roman numerals and maybe some things that you might not have encountered when working with Roman numerals before. I thought I'd do something this time around a little less heavy. I usually do quite a sort of heavy session at MathsConf, and I thought maybe just do something a little bit more playful, looking at some numbers. So that's what I'm going to try to do. So let me just jump over to my slide. I have to apologize. I'm using lots of different computers here, and I have the chat on a different screen. So let's get going. I'm going to talk about Roman numerals in lots of different ways, and maybe ask you to do some work. So it'd be really helpful if you have a pencil and a piece of paper to have a go at some bits and bobs. And it would also be really helpful if, when we're having a go at a few things in the chat, you throw in some of the answers that you're thinking of as they're coming up. Okay. So let's just start as though nobody knows anything about Roman numerals, which is obviously not going to be the case. Roman numerals is a strange thing to have in a mathematics curriculum. And recently, fairly recently, the English national curriculum made a bit of a thing about including it on the program of study for primary schools. And it's a kind of unusual thing to have on there, because when we're learning mathematics and learning anything at all, we're taking part in the process that is kind of ratcheting up humanity's knowledge bit by bit. So what I refer to as cumulative culture. And as we are learning anything in school, really what we're doing is time traveling. School is a bit like being able to step forward millions of years in time, because if, as an individual, I had to learn everything, I had to come up with everything, I had to invent the mobile phone or the car or calculus, I couldn't possibly live long enough to do that. And what we're doing through education is allowing pupils to take this time traveling experience. That's what a good education is. It's equivalent to taking a great leap in time and the thought that you're doing. And bit by bit, generation by generation, we add to the knowledge base. And we're only able to do that because we're standing on top of the previous knowledge base. If you think, for example, of Isaac Newton and Albert Einstein, well, Isaac Newton and Albert Einstein had almost identical, in fact, identical physiological apparatus as you do and as I do. If you think of the neurons in your brain, the chemicals there, the electricity that's going on there, they had the same physiological tools. But Newton was, even though he took a huge leap with the calculus, he wasn't able to go further and think of the sort of things that Einstein thought of. And that's because it required the couple of hundred years between Newton and Einstein, that couple of hundred years of additional thinking, such that Einstein is able to make that next little ratchet up. And one of the things that's very odd about including Roman numerals on the national curriculum is that for a long period of time, Europe was held back in its development because of the adoption of Roman numerals. Using Roman numerals, the tools that we use to do mathematics, the medium that we're doing mathematics through, whether that be language or symbolism, has a massive impact on how we think mathematically and what we're able to do mathematically. So it's a strange inclusion. It has this bizarre impact on the ratchet effect. So Roman numerals were basically a direct copy of Etruscan numeral system, which had come before. And as the Roman Empire started to take shape in 700 or so BC, the Etruscan, which was a mix of different cultures, the Etruscan culture was one of the dominant ones. So that made sense that they took the dominant numeral system and used that. So it's basically a copy of that. And Etruscans have symbols for 5 and symbols for 10 and so on. And it's not unusual. It's quite hard to get away from the fact that we have 10 digits. It's not unusual that base 10 is so prevalent in number systems historically. And these started to become the generally accepted form of writing numerals from about 500 BC. This Roman numeral practice. There'd been lots of numeral systems before this, but from around 500 BC, these started to become really popular. And at that time, and for a long time afterwards, across Europe, there were many, many different numeral systems in play. People using all sorts of different symbolism, all sorts of different ways of counting and recording, particularly ordinal numbers. So you have this massive variety of different number systems in play and in use. But for about 1500 years, Roman numerals across Europe did become the dominant model. They became the dominant way of representing numbers through symbolism. 1500 years of this numeral system that has really serious problems behind it and does have a massive impact on cumulative culture. And this is the dominant system for about 1500 years before Hindu-Arabic numbers start to replace that in the 10th century, 11th century, where people start to use Hindu-Arabic numbers, the numbers that we use today. And they start to gain importance in the 10th or 11th century. Mathematics is much more powerful with this Hindu-Arabic system than it is with Roman numerals. And people could see this, but even with that, it then takes many hundreds of years for them to properly displace Roman numeral systems. So all the way through to the 16th century, the Roman numeral system remains the main numeral system across Europe. And as I said, this has a big impact on our ability to do mathematics. It's terrible for arithmetic. We have no negatives, we have no zero, no efficient algorithms for working. So the mathematics that's happening across Europe in that period of time, after an enormous explosion of mathematics under the Greeks and the Babylonians, the Romans kind of put a pause to that acceleration of mathematical knowledge with this numeral system, and has this big impact. So it's an odd thing to include. However, even though it is now several hundred years following the falling out of use, Roman numerals are still everywhere, and we do see them all over the place, whether it be in regnal numbers or Pope Benedict XV or whatever it is. But you'll see them in date stones, you'll see them in bullet points, see them in sequels to movies, all that kind of stuff. So they hang on in there somehow, even though their use for mathematics is really quite limited. I want to have a play around with these numerals for a while and maybe encounter some things that you're less familiar with. There is no formal system of Roman numerals, and there never has been. There is no accepted way of using these numerals. There are more common ways than others, but there's no set of rules, no laws as to how you use these. Now, generally, we'd think of them with these symbols here. These would be the most common symbols. So we use an I to represent 1, we use a V to represent 5. All sorts of mythology around why is it about the crossing of hands and things like that. Lots and lots of mythology. The answer is we don't really know, but Etruscan symbols also had a symbol for 5, X for 10, L for 50. Really modern, most of these. C for 100. C, you think, century, that feels like that must have been one of the early ones and important ones, but actually lots of what we use, lots of the ways in which we use Roman numerals is really quite modern. D for 500 is a modern invention, as is M for 1000. Now, when I say modern, I don't mean last week, I mean in the time scale of the last 2000 years. So most people would be very familiar with using these symbols, and this would generally be the set of symbols that people consider to be Roman numerals. But as I said, there is no formal system. There are no rules to this. And Roman numerals have this serious weakness of not having a zero. So Roman numerals are a non-positional numeral system. The lettering, the position of the letter doesn't tell you anything about its value. Whereas when we're using Indo-Arabic numbers, the position matters a great deal. It means we can use a very small number of symbols, and it means we can be really quite efficient in how we write out numbers. And the zero in our number system tells us there are none of that place value available. And it's a real difficulty that Roman numerals don't have a zero. There is use of the word nulla, which means zero in Latin, or nihil, which means nothing in Latin. There are examples of those words being used to communicate literally 1 minus 1 or x minus x. What is the answer to that? And sometimes you see the use of n. However, n itself is a Roman numeral, and n is the numeral for 90. So it's quite confusing that some people use n for 0, but n is also used for 90. So we have that weakness with it. And we end up with this system here that we're all familiar with. And this does look really very familiar when we look at this. This is the standard form for Roman numerals. Now, when I say standard form, what I mean is there is a legal definition of Roman numerals where it's used in law. It's used in lots of copyright law, for example. And these are the numerals available in that. Note that the highest number you can make in here, because it only goes up to 3,000, there is no standard form above that, MMM. There's no standard form above that, thinking, well, actually, it will hold true for copyright law for all of the time that we're going to be alive if we need to be writing down years. So this looks very familiar, and lots of people convince themselves, well, this must be it. This is how you write Roman numerals. But that just isn't the case. As I say, there are no rules to this at all. So the largest number you can make in that particular system is 3,999. But that's by no means the largest number that can be made. And if we were to write that down, so if I ask you to write down 3,999, I'd imagine almost everyone would write this kind of format. And we have this subtractive form where if there's a smaller digit to the left, we subtract, otherwise we're going to add. So here we've got the numeral saying 1,000 plus 1,000 plus 1,000. Then we've got a smaller numeral before a larger one, so we do a subtraction, 1,000 minus 100, and then a smaller before a larger, so we do a subtraction, 100 minus 10, and then we do 10 minus 1. And we're all very familiar with that, but it is not the only way of writing this number. And it's certainly not the only way that the Romans would have written this number, or indeed medieval period would have written this number. And it's quite long, isn't it? That's a long old numeral to have to write down. It is the case that this is also 3,999. So we got 1,000 plus 1,000 plus 1,000. Then when we have a smaller in front of a larger, so we do the subtractive form, and we do 1,000 minus 1, and we get 3,999. A lot of people get quite uncomfortable seeing that because we're so used to the other form. But many people used variant forms of writing down these numbers over time. And one place you can see this in modern day usage, for example, is if you were to use the Roman function in Excel. So if we jump over to Excel, well, here I have some numbers, and what I'm going to do is convert them into Roman numbers using the Roman function. So the Roman function is we write the word Roman, and then whatever the number is, and then the format. And there are 5 formats in Excel. There's 0, which is referred to as classic, and actually it means the standard, the legal one. Then there's a concise, a more concise, a more concise, and a simplified. So if we look, for example, here, the number 499 in standard CDX, CIX, but it is true that you can write 499 as ID, and you can write 499 as ID and many other ways as well. If you're unfamiliar with Roman in Excel, so we put equals Roman, and then it's whatever we're referring to, and then the format. So it's either 0, 1, 2, 3, 4, and we'll get different answers to these. So if I just drag these across, they're all I for 1, but if I fill these all down, then you'll start to see variations happening. as these numbers start to appear, we end up with different types of Roman numerals representing the same number. So, for example, here, look at 49. So 49 XLIX, 50 minus 10 plus 9, but also VLIV, 50 minus 5 plus 4, but also IL, 50 minus 1 in different formats. It's quite an interesting way to quickly get to see some of the variations. Look at 95 here, XCV. Yes, okay, so 100 minus 10 plus 5, but it's also true we can write VC, 100 minus 5. So the Roman function in Excel is quite a nice way of looking at some of the variations that exist. There is no set of rules as to how Roman numerals are written. There is no one way that we have to follow at all. They can be written in lots and lots of different ways. Look at 249 here, CCX, LIX, but also CCIL, 200 plus 50 minus 1. That's a really important thing to get into. If we're going to spend time on our curriculum working with pupils on Roman numerals, we really should be going much further than just this standard form. There's not a great deal of mathematics they're getting out of that. Yes, there's some interesting things about historical numbers, but we can do some really interesting maths rather than just the historical case. Here, for example, how many ways can you count up to 10? There's a nice question to ask a bunch of year 4 pupils. How many ways can you count up to 10? And they'll be used to this sort of way. So we get I, V, V, and so on. And it's very standard, but that isn't the only way in which you can do this. There are lots of ways in which you can do this. So yes, it is true that that's one way of looking at it, but it's also true that this is a way of looking at it. And isn't that painful to see that? So I written out as 4, VII written out as 9. It feels really uncomfortable. VV as 10, but these are all permissible. They're all allowed in the system. So a question we might ask year 4, instead of just write down the numbers 1 to 10, is how many different ways can you write down the numbers 1 to 10? And there's things about number bonds going on here, and there's things about combinations going on here. Let's have a look at another one. So that's quite uncomfortable, isn't it, seeing that? Certainly seeing that's uncomfortable. What about this one here? This is very common. So 5 written as 1, 2, 3, 4, 5, and not as a V. So more like a tally, but a tally that hasn't been crossed. And it's also common to see all the way up to 10 just written as straight lines, notches on pieces of wood, notches on stone. Look at this one here, IIX. Okay, that feels uncomfortable as well. Now, we usually write VIII, but why do we do that? This is just as efficient, and it clearly says the same thing. So it's quite a nice question to be asking. And also this notion that IV is the number 4, well, actually, the most common place you see Roman numerals, I would suggest, is on clocks or watches. And almost all clocks and watches have 4 written as III, not as IV. So we get III written out rather than IV. One notable exception for that is Big Ben in London, where it is written as IV, but most clocks and most watches don't use IV. So how might we write out, for example, the number 999? I'm just going to pause for a second and ask you to have a go at writing out the number 999 a few different ways, maybe 3, 4, 5 different ways, and pop them into the chat as you're doing that. So I'm just going to pause for a second and give you a moment to do that. Okay, some really interesting solutions coming through there, all sorts of different ones. And this is the kind of thing, if you're working with very young children, isn't this a more interesting thing to be doing than just sticking to that one? So here are some possibilities. I like the ones in the chat. So I like did, that's really nice, DID. So most people would write out CMX, CIX, the kind of traditional way of doing it, I guess, for most of us. But what about this? LMV, LIV? That's 1000 minus 50, then 50 minus 5, and then 5 minus 1. It's going to give us the right solutions. And now we're getting into the pupils working with lots of combinations of arithmetic, practicing bonds, and so on. What about VMIV? So 1000 minus 5 and 5 minus 1. Again, going to give us the solution. One of the things you might ask pupils all the time is, can you come up with the most efficient way of doing this? Well, I guess IM is the most efficient way, and I've seen that a few of you have popped that in the chat, IM, and it's a really efficient way of doing that, and that might be one of the tasks that you set pupils. Always find the most efficient way of doing that, writing out the numbers. So let's move on. How many ways might we write out 99? Well, we might do the usual. So we're going to do 50 plus 10 plus 10 plus 10 plus 10 plus 5 plus 1 plus 1 plus 1 plus 1 plus 1. Or we could do something like this, 100 minus 5 plus 4. So that's 99. Or something like this, which is a really uncomfortable one. It's like that VV earlier on. I like it just because it spells a word, and I've found that pupils often find that quite a funny thing when they can make words out of these. And there's a whole thing of chronograms of using Roman numerals to write secret codes about your name and so on. That is another interesting thing to get into with pupils. What about this number here? What number is this? So just give you a moment. Have a look at this carefully, this number here. What number is being represented here? So if we use our subtractive form, get 10 plus 5, and then there's a smaller before a larger. Okay, so that's a 9, but then there's a 3 after that. It doesn't quite make sense, does it? So what on earth is going on here? Well, this here is being driven by the way in which people speak. So think about how some words are said, and the language that you use, the medium of language that you use has a massive impact on how we do mathematics and how we think about mathematics. You see, this one here is 1613. So there was nothing to indicate that there is a separation here. And this is taken from Padlock, and there are lots of different examples of this, with years in particular being written in this really strange way, where it's literally, they just write 16 and then 13. And we have to use our knowledge of the context. Clearly, this lock is referring to a year. We have to use the knowledge of the context to decipher what's being written here. And that is how you would say it, right? Nobody really says, when they're talking about the year 1613, nobody says 1613. We say 1613. So that's what's been scribed, 1613. So it's another interesting example of that. And there's lots of those that exist all the way back for a couple of thousand years now. What about this one here? So let's take a look at this carefully. What is this saying? And again, think back to what I was saying a moment ago about language. The medium that you're using has an impact. So what number is this here? And I'll give you a hint. And the hint is maybe you're slightly old-fashioned English, or maybe you're just French. So what is this? What number are we looking at? Well, if you're slightly old-fashioned English, we might think of this as 4 score. So when it's got superscript, sorry, it can be subscript as well, actually. When it's got superscript like this, we're doing multiplication. So this says 4 score, or 420s. And if you think of the way in which French numbers work, if someone wants to say 80, 420s for 80, 80. They don't say 80, they say 420s. And lots of people who are a little old-fashioned in English, 4 is a way of saying 80. So this is saying 4 multiplied by 4 multiplied by 20 to give us 80. And this language thing really matters. So looking at some of the French numbers here, as we get to this point, building up. So we start on 1 and then 11, 21, 31, it all looks about right. So we're saying this amount plus 1, this amount plus 1, and this all makes sense. And then we get to 61, so 61, but then suddenly 71. So instead of doing 70 and 1, we do 70 and 11. And this has an impact on the way in which Roman numerals are written down, depending on how the culture uses number phrases. So 83, for example, we might see 83 as being LXXII, so 50, 30, 3, okay, putting it together in this additive form. But another way of thinking of 83 is 4 20s and 3. And if you imagine 83 being said in French and in lots of other languages that would use this same kind of approach to building the numbers, 4, 23. So that language is determining the way in which the number is being written out. Some other examples of that. Remember, the superscript is about multiplication. So here we've got VC. So 5 100, and the 100 is being raised. So it's for multiplication. So here we're saying 5 100s. And again, if you think of us speaking in French, then we're going to say, oh, I've got a letter missing there. It should be sont instead of ont. So we've got 500. What about this one? So XV, so we've got 15C multiplied. So 1500 19. So 1519. 1519. And then this one here, we're using our superscript again. So 99. And we're getting the number 99. So now we know we can also use superscript for multiplication. I'm going to give you a moment to come up with as many ways as you can write 99 as possible. So we've got lots of different ways of doing 99. Can you throw in some where you're maybe using superscript as well? So I'm going to pause for a moment and give you a little bit of time to do that, and I'll look out for your answers in the chat as we go through. Okay, so some interesting answers coming through there. It's really nice answers there that I've never seen before. So what about IC? So if you were saying the most efficient one, we could do IC. And then one I was looking at a moment ago, I really like that one because we can connect it to the pupils are probably going to be learning a second language, and in many languages, not just French. If you were doing Latin, for example, we're going to compose our words for numbers in a very different way. So I quite like that. IX to the power, IX raised to X to I. Nice, I've never seen that before. Some really nice ones there that I haven't seen before. So some different ways of pulling these numbers together. And already we're getting these young pupils that are working with Roman numerals doing something much more meaningful than just learning a list of 5 or 6 symbols and then learning how to write down the numbers 1 to 10 or 1 to 100, whatever it is. We can do much more interesting, meaningful things than that. What about this one here? IIXX. Now, what number is this? IIXX. Just give you a moment to think about that. perhaps being slightly naughty here, because this is sometimes 18, but it's also 22. And this comes from the way in which language is constructed. So if we think of the 22nd legion of the Roman Empire, the way in which that wording is constructed, so geo et vicissima, 2 and 20th. So the 2 comes first in the way in which we're saying it, 2, and you can see the symbolism as a 2. And you see this etched into stone from many, many hundreds of years ago, referencing the 22nd Legion. And it's this way of constructing the language. And as we all know, as maths teachers, the language we use has an impact on how readily pupils grip working with mathematics, grip arithmetic, and so on. So I think that's really quite nice, seeing those different formats. And if we think of the way in which we say some of our numbers in standard English, well, this would be 21. What's going on here? The one's pretty obvious, right? What is this 20? What is this meaning? Well, clearly it's meaning 2. The twa bit is the 2, and the ty, what is the ty? This is the 10 bit, right? So we've got 21, 22, 31, 32, and so on. 71, 72. Because unlike French, we do have a 70 version of it. And it's the 7, so we're taking the 7 and we're putting the ty on it to say there are 7 10s and 1. Yet then we have this really weird situation with this numeral and this numeral. How should they be said? And obviously the way in which we say those are 11 and 12, but would it not make arithmetic much clearer? Would it not make things much more straightforward for pupils if we referred to these as 1t1 and 1t2? So 1, 10 and 1, 1, 10 and 2, and we're seeing how the number is being constructed and built up. So why is it that we have these different words for 11 and 12 that don't fit the rest of the pattern? Well, let's take a look at this number. What number is this in Roman numerals? So IVS. Just give me a moment to think about that. IVS. What number are we talking about here? IVS. And this might be unfamiliar to some of us if it's been a long time since we've thought about Roman numerals and looking at Roman numerals. IVS. IV, we're talking about 4, aren't we? But what's this S symbol? Well, S is the symbol for 1/2, because Roman numerals do have fractions, and fraction work in Roman numerals has always been commonplace and always been part of their usage. So Roman numerals absolutely do have fractions. So IVS is 4.5, and the S semis is where the S comes from. The half isn't referring to a half in quite the same way as we might expect it to, because Roman numerals to this point seem to be in a sort of base 10 situation, right? The 10 seems to be what we're working with, but S does not mean 1/2 in that normal way. It means 6/12. So when we're working in fractions in Roman numerals, the numerals are in, or the most commonly used ones are in 12ths. So let's take a look at those. So S is 6/12, 1/2, halfway between. A dot, a single dot, is 1/12. 2 dots is 2/12. 3 dots, 3/12. 4 dots, 4/12, and 5 dots, 5/12. Then when we go beyond a half, we say a half and that. Okay, so it's going to be S 1 dot, S 2 dots, S 3 dots, S 4 dots, S 5 dots for 11/12. And then obviously 12/12 is the unit. So we're back at I. So we don't have to restrict ourselves to working with integers when we're working with pupils and introducing them to Roman numerals. Let's get some fraction work in there and work with do some more interesting fraction work. We've got examples of these fractions appearing. So here are some examples on some coins from many years ago with the 4 dots on there. And we might also talk to pupils about how we say these words for these fractions, because pupils, even very young pupils, they're going to recognize a lot of this, right? Quadrands, they're going to have heard something sort of like that word. So if we look at 1/12, 1/12 means ounce, and there's a word they're going to recognize. So twelfths are ounces in Roman fractions. And then we get these words that they're definitely going to recognize some of these things. So we've got sextants, for example, quadrands, triands. These are going to be familiar things to pupils, and we can have that conversation about the derivation of our words, the etymology of our words. This is a really interesting one, isn't it? 8/12 is bez. So twice, that means twice. Why does it mean twice? Well, because it's referring to 2/3. So it's twice 2 lots of a third. And then we start getting into the less than as we head towards the unit, and as is a unit. And we're stepping back. So 11/12 is less than an ounce. So less an ounce, sorry, less an ounce than a unit, less a sixth, less a quarter. And using this opportunity to have this discussion around these words with pupils allows them to see connections across the etymology of words in other places as well. Some people, it doesn't matter how young they are, when we see the word septunx, somebody's going to talk about, is this related to September? And we can open up that discussion. So we can also use fractions. They're the most common fractions, but here are some others. So there are lots of fractions in Roman numerals. 1/8, for example, sigma dot, 1/24 sigma. There's a really interesting one at the top there. So we've got 1/1728. Why is that? Why 1728? So we've got 1/1728. We've also got 1/144. I'm sure you can see that what's happening here is 144 is 12 squared, 1728 is 12 cubed. So it's back to relating to twelfths and talking about those twelfths as being the main thing that we're looking at, those ounces or indeed inches. So we might ask pupils, given that the Romans were pretty much working in base 10, why would they choose twelfths for their fractions? Why shift away from the 10 and talk about twelfths? And we can ask the pupils to have a conversation about that. Now, clearly what's going on is that 12 has many more factors. We could use a base like base 60, for example, that has even more factors than 12, but there'd be so many symbols to remember for base 60 as previous civilizations had done. There's so many symbols. The complexity of the symbolism maybe outweighs the flexibility of the factors that it gives you. So we're using twelfths because twelves are very much easier to work with division. So they were using this base 10 then when we're moving into base 12, and we can talk to them about how it's much easier to divide quantities in twelfths and work with twelfths. If you find 1/3 of 10, or 1/3 of 10, 0.333 forever and ever, and already things are starting to get a bit sticky, but 1/3 of 12, there we go, we have a nice answer. And then we could ask pupils, what other bases might you work in? Can you think of some examples? So I'll just pause for a moment and we'll do that question. So if you're a group of year 4 pupils and I said to you, think of times where we're not working in base 10, think of times when different bases are appearing, think of commonly used ones you see every day. So what other everyday bases might you encounter if you're a year 4? So you're that age group, or perhaps a little younger, and we're having that conversation. What things might they come up with? There are lots of ones as adults we know, binary and so on, that's used in computing languages, but what might a year 4 come up with? Just give you a moment to a little think about that. And typically year 4, that kind of age, they're going to come up pretty quickly with things like time. So 1 hour isn't 10 minutes. Seconds, 1 minute isn't 10 seconds or 100 seconds, despite attempts to do so previously. So they might start talking about time. So we've got hours, minutes, and seconds, which means we can introduce a sexagesimal system and talk about that and other places where sexagesimal has been used over time. Weeks, well, 1 week isn't 10 days. Again, there have been attempts to do that. And when Roman calendars started, we were talking about 9 days in a week or an equivalent. So we have the septenary system, 24-hour clock. 24-hour clock is an interesting one to, again, have that conversation about language. Because if we look at the way in which that word is built up, tetra, and we can talk about why that means 4. So introducing these different ones, 24-hour clock, slightly different. Degrees, again, look at the way the word is built up, 3 100s. Okay, so enable us to talk about etymology, and most pupils will come up with degrees. Some pupils will be used to writing colors in programming. So if you're trying to get the color white, and you're writing HTML, you're going to write FFF, and if you're trying to get the color black, 0000000. So they'll come up with those things, perhaps some of them. And then you might have pupils that talk about music. So how many notes are in a bar? 1 bar might be 4, and so on. So there are lots and lots of ones that will emerge from here. And we can have a really nice conversation with pupils about different bases, the benefits of working in different bases, and what comes from that, and why we favor base 10, but still use other bases in so many different places. And perhaps one of the questions we might ask, and they might say years, a year doesn't have 10 months, it has 12 months and so on. So that might come up. And we might pause on that one and say, are you sure about that? How many months are in the year? And how many months were in the Roman year? And we might have that conversation with them, which will allow us to reveal that in the Roman year, certainly the legendary Roman year, this obviously changed over time as people learn more and more about how the year evolves, but the legendary Roman year has 10 months and just 10 months. And those months start on what is effectively the same month as March, and they go through to December, giving us a year of 304 days. So there's quite a big gap missing in the year. Young pupils will know the year is not 304 days. So what on earth happens next? If we have just 10 months, what happens after that? Well, what happens after that is winter and the dark times. And these, at this time, these months aren't even bothered to be named. So we have the 10 months that are fruitful and can be useful, and then we have winter, and we don't give those months any names. So we have 10 months and then this blank period in the calendar that exists for winter. And there are some arguments around, did that really happen? Was the 50 or so days that were set aside to be the dark months rigid? Was it always in winter? And some people will argue, actually, it just moved around. So this blank period ended up moving around the year. But most evidence suggests that those dark months are winter. And that's an interesting moment for pupils to think, well, hang on a second, I thought there were always 12 months. Well, no, there weren't. There weren't always 12 months, and different cultures have taken different approaches to how they measure Earth's progress around the sun. And then we might ask them some interesting questions about our calendar and when did it start? And as we all know about year four think that someone who's 50 is basically, ancient as the dinosaurs. So they have a strange concept of time. So we've got some interesting questions here to ask them. When did this first come about? When did we have our calendar? And pupils will, in my experience, pupils will say for thousands of years. This has been something that's been around a really long time. And that allows us to ask some really interesting questions about our own calendar. So for example, if I ask you, what date immediately followed the 31st of December, 1750? What's the next day? 31st of December, 1750. And I guess most people would think, well, it's the 1st of January 1751, isn't it? But no, it wasn't. It was the 1st of January 1750, because at that time, January was not the first month of the year, March was. So that's quite an interesting thing. What about this question? What date immediately followed? What was the next day after the 24th of March, 1750? So I'll give you a moment to think about that. What's the date immediately after the 24th of March, 1750? And we think, well, probably the 25th of March, 1750, right? And no, it wasn't. Not in the UK, it wasn't. So the day immediately after the 24th of March, 1750 was the 25th of March, 1751. Let's try another one. What date followed the 31st of December, 1751? Well, the day immediately after the 31st of December, 1751 is the 1st of January, 1752. And this is the first moment where January is the first month of the year. And then one final question we might ask, okay, what about the 2nd of September, 1752? What's the day immediately after the 2nd of September, 1752? And then this one always makes the pupils laugh and always makes them sort of be bewildered. The date after the 2nd of September, 1752 is the 14th of September, 1752. And this is the final alignment, putting right some of the adjustments that were needed to the Julian calendar, because you get this slippage. This is us moving over to the modern calendar. And making up these days here is why, for example, because the 25th of March used to be the first day of the year. So that used to be New Year's Day, 25th of March. And this gap that we have, if you think when the tax year begins at the moment, the 6th of April, that gap is introduced by these missing days here. That's what's going on. So the 6th of April is the old 25th of March, which was the old first day of the year, and that's when the tax year was beginning. And there are just these little interesting snippets that we can talk to pupils about because we've been talking about these different bases. What about pi? So we had a fraction a moment ago. Well, if we look at Frontinus in 98 AD, one of the most important books written in Roman mathematics, we have this written down, and let's assume our Latin isn't quite what it used to be. But what Frontinus is doing here is effectively describing squaring the circle. And it is from this piece of text here where he's laying out the rules as to how he goes about doing this calculation. It's from this piece of text that we understand what the Romans used as pi, because this can be represented mathematically. These two situations, one's a circle, one's a square, can be represented mathematically like this. And if we solve for pi, making a equal to 1, so a unit circle and unit square, and solve for pi, we end up with, in both instances, 22/7. And that's what the Romans were using. It's a pretty good approximation. That's what the Romans are using as their approximation to pi. And we get that from that little bit of text there. And that's something maybe not for year 4, but you might want to ask some secondary pupils to unpick that. Let's take a quick look at some large numbers before we stop. Suppose we wanted to write 500. Well, 500, we could write C, 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 C. Okay, and that is older than writing D. But there is a convention that allows us to multiply by powers of 10 and 500. So if I write 1, I, and I put an apostrophus, a single apostrophus, looks a bit like a bracket, to the right-hand side of that I, that is now 500. So this is saying 1 multiplied by 500. But if I put 2 apostrophus symbols, I'm going up in powers of 10. So that's 5,000. And then 3 apostrophuses obviously will be 50,000. So apostrophus to the right is going up in powers of 10, starting at 500. If I take 1,000, which I could write like this, lots of M's, very inefficient. Another way of doing that is to use apostrophus. And if I do apostrophus on both left and right, I'm now multiplying by powers of 10, starting at 1,000. So this is the number 1,000. If I put more apostrophuses on either side, this is 10,000. More apostrophes, 100,000. So apostrophos is a way of allowing us to write really large numbers. And the Romans did write really large numbers, particularly when they were talking about traveling from place to place, and talking about Roman miles. If I wanted to write 100,000 in the standard way, well, I have to do this, and let's speed that up. That's going to take a really long time. So they needed a more efficient way of doing this. And apostrophos is one way of doing that. So we have one to the right, 500s, and then powers of 10, and then encased for powers of 10, starting at 1,000. Another convention that might have emerged from that, so you can see this was I, then apostrophos, there is an argument that that's where the D came from. Seems quite convincing, right? And then John Wallis, when writing about infinity, there is, and it's probably just apocryphal, but there is sort of this suggestion that he used this symbol here and used 1,000 as an arbitrarily large number to come up with a symbol for infinity. I don't buy it myself. Maybe you do, but I'm not quite sold on that. Another way of writing really large numbers, rather than using apostrophos, is to use a vinculum. So here we have the number 7, but if I put a vinculum above that, then this multiplies this by 1,000. So that becomes 7,000. So a vinculum gives me 7,000. So these numbers, for example, are ways of writing some quite big numbers. So 4,949, I write 4,000 and then the rest of it. 6,354, 6,000 and then the rest of it. 9,972, 9,000 and then the rest of the number. So it's a much more efficient way of writing these. So let me ask you another question then. Can you think of ways of writing 14,072? I'll give you a moment to come up with that. 14,072. Can you think of some ways of writing that? We have all our different things available to us. We have apostrophos, we have vinculum, we have superscript. How might you write that? Let's have a look at some possibilities. Well, we could write the whole thing out like this, 14,050.22. That's a bit laborious. Or we could write this, 14,000 and then 3 score and 12. Or maybe we could write the 9,000 and then add, the 14,000 with apostrophos and then add on the other terms. So lots and lots of different ways of doing this, and asking pupils to find these combinations is a really nice thing to do. And then just one last convention. We can use a vinculum, a horizontal vinculum, and then we can use vincula at the side as well, vertical lines. And what this does is multiply by 100,000. So this number here that we're looking at is 700,000. This allows us to write really big numbers. And if you are sending a legion of troops from Rome to some far distant land and you need to know the number of miles or 1,000 Roman steps, then these numbers do start to become important. So the final question I'm going to ask you is, can you come up with ways of writing 1,332,000? I'll give you just a moment to try that. There are loads of ways of doing this, but here's a nice way. If I did this, so look what's there, 1,300,000. In other words, 1.3 million, 1,300,000, which leaves 32,000 that I need to add on. And I can do that like that. So there's a little exploration of some other things you might do with Roman numerals beyond just teaching the standard small number of letters, some things you might ask pupils to engage with, and perhaps that unpacks some historical context, etymology, and some interesting things to talk about beyond let's just count to 10. I hope that's in some way interesting. There's a 5-minute break now. Grab a cup of tea and then head off to the second workshop. Thanks very much for choosing this workshop. Any questions, any thoughts about that? I'd be really pleased to hear from you. Do give me a shout if you want to talk more about that. The slide deck will come out to you, obviously, and the recording will come out to you as well. So thanks very much, everyone. Enjoy the rest of the conference. Thank you. Bye.